we're going to take a second look today at the fundamental theorem of algebra and this remainder theorem. But we are going to throw one small new thing into the fray today. And that is, I'm going to give you a graph. And we're going to use the graph to write the equation in factored form. Now, we did a version of this yesterday where I gave you the zeros. Okay, we're going to find the zeros today. So here's kind of what we're going to do. We're going to three-step these. Okay, first, my first job is going to be to find the zeros. So once I do that, thank you. Okay, so my first job is to look at the x-axis, because again, zeros are x-intercepts. So I look along here, and any place I see my graph touching or crossing the x-axis is where my zeros are. Sometimes that may be obvious, other times it may not. Okay, so for our instance here, step one, it looks like we're at -3. We're at 0, and that one we're going to chat a little bit more about here in a second. And we're at 1. I'm just going to write them down. So first job, find my zeros. Second job, we need to turn them into their binomial form, which just means we're going to take these and when it says x minus b, all that means, and we said this yesterday, is I'm going to take the opposite of whatever sign I see when I'm putting them into the parentheses. So I'd have x plus 3. Whenever 0 is one of yours, and we're going to talk about 0 now, like we've talked about before, we can just use x. But here's the kicker. Yesterday we talked about when we have something called a double root, something that bounces. Notice here that my graph comes up to the 0 and then it goes right back down. It doesn't really go through. So this one is one of our double roots. Well, what does that mean? That means we're going to put it in here twice. So we're going to have x, and we're going to have x, because anytime it just touches and then goes back down, it's going to be a double. And then my last one, I switch the sign on my 1, and I get -1. You're like, that's kind of weird. It's true. So that's getting them into my x minus b form. Again, 0 is the only one that I'm not going to have to do the changes with. And then finally, we're going to multiply them all together. Now this can be a challenge sometimes based on the way things look. But here's a couple of things I can do to simplify this. Okay, I'm going to rewrite number 2 here for a second. X times x is x squared. And let me rewrite these next to it. There's a couple of different ways I could tackle this. Most of the time, personally, I'm going to deal with the parentheses first, and I can only do them, 2 pairs at a time, 2 sets of parentheses at a time. So, when I get to this next part, again, I am the box guy. That's how I do my thing. I got to watch for my signs. I'm going to zoom in here a bit. So for those of you seeing this later, apologies if I make you feel blind for a minute. Okay, that wasn't too bad. And again, when we're multiplying, we're going to add our exponents. And we multiply coefficients. So once I get that box filled in, I'm going to go ahead, I'm going to get that cleaned up, I'm going to combine my like terms. Again, once we fill the box, we're not messing with the exponents anymore. 3x minus 1x is 2x. Minus 3, but I still have one little piece left because I took care of these, but the x squared's still sitting here. So my last job is going to be to distribute my x squared through. And since that's just one term, I suppose I could make a box, but I really don't need to with only one term. So I'm adding my exponents. And I've got my binomial in its completely worked out form. Now, here's the other thing that I'd kind of start making connections a little bit with what we did yesterday. When I get to the end, I should have a little clue on my head what degree it should be. Because my degree is going to match the number of zeros that I have. So here I've got 1, 2, 3, because it's a double, 4. So when I get to the end, I know I better have something with x to the 4th, or something didn't go right somewhere. I didn't add my exponents, something. Or maybe I forgot a double sometime. That's something else that can happen with these. Okay? But those are the 3 steps I've got to do to get there. Find my zeros, see if any are doubles, switch their signs to get them into their binomial forms, and then multiply them together. And we're going to do one more, because I want to make sure that we're kind of getting some good examples to work with before we do some on our own. So we're going to go to that last one down here on number 4. So kind of give me some space here. So again, I go through. Goes, okay, step 1. Find my zeros. I'm gonna make an executive change to something here, so it's not as difficult to deal with because I boneheaded and picked this one. We're going to miraculously shift this one over to -4 instead of having it be at -3.5. We could do that, but ugh. And no, you do not get executive privileges to move any numbers wherever you feel like it. Okay? I got to get some benefit out of some things here of making these. Okay, so my first step here, my zeros. First, my miraculously moved to -4. -2, and +1. I don't have any doubles this time. I don't have any that bounce up and barely touch it and go back. So I have 3 zeros. So when I get to the end, I should have a degree 3 polynomial. Step 2, switch all their signs. And now I've got to go back and take them a pair at a time. I can't do all 3 at once. So any pair is fine. Again, if you're a foiler, as long as you remember that it's not just first and last. That's why I like doing it this way, because that way I have to fill the box to make sure everything's there. Again, we multiply to fill the box. And once the box is full, adding my exponents, multiplying my coefficients, I'm going to go back and look for my like terms and get those combined. Now, that is not the end for a couple reasons. One, it's only x squared, and I know with 3 intercepts, it's got to be x to the 3rd. Secondly, because there's still one of these I haven't used. So, one more time, with the x minus 1 that I have left from here to go along with my answer from the first part. Again, I like to put my 1 exponent on my x's so I don't multiply them and think, it doesn't change at all. 1 plus 2 gives me x to the 3rd. 1 plus 1 is x squared. 8x. And now the -1 is just going to change the signs on all of the terms up here. And once I get these like terms together, I'm done. So x to the third. Again, once the box is full, we're just combining like terms. We're adding and subtracting. 6 minus 1 is 5. Negative 6 plus 8 is 2. Minus 8. I have a third degree polynomial to go with my 3 zeros. Woohoo! So that's what we're looking at here. The zeros will tell me how big my polynomial is going to be at the end. Okay, we're sort of working backwards from what we did yesterday. Any immediate issues? Got to follow the 3 steps, though. Okay. So as we flip over, now it looks a little bit like what we were doing yesterday instead. Write an equation given the following. Okay, zeros, degree, and then they give us some other info. Now, degree 3 means at the end we're going to have something with x to the third. You're like, but wait a minute. They only gave me 2 zeros. If they gave me 2 zeros and it's supposed to be 3, what the heck? That's what our little note's for. 3 has a multiplicity of 2, which means there's a second 3 in there. I'd probably write it out like that. Because now I see there's 1, 2, 3 zeros. I'm supposed to end up with x to the third. So now I can say, okay, so that means I'm going to have x plus, whoa, Harty, whoa, x minus 3, opposites, Harty, opposites, x plus 5, x minus 3. And I work my way through that like I did on the other one. This is good for some of you where we're still having some issues with foiling and multiplying things out, which is kind of why I went this direction. So I look at this and I go, okay. And it's also going to get you faster at this. You can do them in any order you want. If you wanted to do the x minus 3's together first, you could. You absolutely could. And so I get here. And I combine my like terms. Now again, that's not the end, because I know it's going to be x to the third at the end, and I'm only at x squared. So I've got one more of these guys to deal with. And I wish I could say that there was like some speedy shortcut way around dealing with this, but there's really not. But by the time we do several of these, we're going to be such experts that whenever we do need to box something out, distribute something out, we're going to be better at it. Sort of like if any of you do things where you work out. It may not feel real great to your body when you're doing it, but woo, the results are going to be nice. And that's what we've got to keep in mind here. It's the end result that's important. And the only way we get the end result we want is to keep working at it. Just like you don't get a six-pack eating potato chips on the couch, we don't get good grades in math class by just sitting there, okay? Same idea. Now, because I thought it would put some of you into panic, okay, I want to do number 6 with you. Because some people look at this and go, OMG, degree 5, x to the 5th. I'm going to have to do like 4 boxes on this. No, you're not. Okay, why? 0 has a multiplicity of 3, which means 3 of my zeros are 0. And you're like, what's so great about that? Well, if I look at my other 2 that aren't 0, so I'd have x plus 2 x minus 4. But then the other 3 are just x's. And again, you're like, yeah, how again did that make that easy somehow? Okay. When we're looking at these, we're only going to have to actually do one box. I'm going to multiply those first two guys together. And again, you could do the x's first if you wanted to. I think you'll see here in a second why I'm going this direction instead. Multiplying the edges together. Again, doing it traditionally with parentheses would be fine. But here's what I mean when I say this one's a little bit nicer to us. X times x times x is x to the third, because I'm just adding my exponents up. Okay, since there's only one term here, I really am just going to need to distribute this. So I don't need to keep making all these boxes. Even if you wanted to make a 1 by 3 box, it would work. Add your exponents. I should have a degree 5. I have a degree 5. Woo! Okay. And for the current time being, we are going to skip number 7, because again, I'm not going to put you in a position that we're going to be worrying about fractional zeros. We don't need to play that game right now. I could have been smart and just changed that to a different number, but I don't think I was. So you'll have 1 to work with there too. Okay, one last thing. One last repeat review from yesterday. And we'll be seeing some more of this towards the end of the week. Okay, use the remainder theorem to find the remainder when f of x is divided by x minus c. Use the theorem to determine if x minus c is a factor. Okay? Is the remainder equal 0? That's all we're doing here. Okay? It's not going to be as worked out as it was yesterday, where we find all of the factored format. Because some of these are a little cray-cray for where we're at. So what we're going to do is they're going to give me a binomial. They're going to have this little semicolon. They're going to give me something here. So when I go to do this, I switch the sign back. So if it's minus, it'll be plus. If it's plus, it'll be minus. We'll see both of these. And we're going to do synthetic division on the binomial they give us. So I switch the sign of whatever the binomial is. Do I have any gaps? 3, 2, 1, 0. No degree gaps. That's a nice thing. And for some of you that struggled on the quiz with synthetic division, we're going to get this knocked out because we're going to get the time in here. We drop the first term down. Do not multiply it by anything. First term, whatever it is, comes down. Now the process starts. Multiply by what's in the box. Add down. Okay, take that value, multiply it by what's in the box. Add down. And even if it was a negative and it's minus, just think of it as adding a negative. Okay, multiply what's in the box. Add down. So here's what we're getting to. I know I'm basically focused on the remainder, but I'm still going to rewrite this in a polynomial form, which again, whatever degree you start with, we go down 1 from it, 2, 1, 0. Here is my remainder. Okay, and yes, I need to get the fraction in there. So here, when it's asking me, was x minus 2 a factor? No, it's not, because the remainder wasn't 0. If I get a 0 here, the answer is yes. Yes, that's a factor. That's a 0. But if I don't get 0, if I get anything else, positive, negative, don't care, the answer is no. But we're not going to try, well, here I couldn't anyway because it's not a factor, but even if it was, I'm not going to make you do that other factoring stuff today. Because some of it, like I said, is a little bit higher up than we are. Okay, last one I'm playing with. Number 11. Okay, I look at x minus 2. And I go, all right, switch the sign. So like, for instance, if we were doing number 12, that would be x equals negative 3 that we're going to use. So I get my 2 in here. Look for gaps. 4, 3, 1. Oh. 4, 3, 2, 1, 0, or constant. So when I'm making my values before I start doing my division, 4, 3, 2, I got to get the 0 in there, 1, constant. And you can have more than one 0. So you've got to watch out for that too. There's lots of little things we're looking out for here. Bring my first term down. Again, don't mess with it. We're not multiplying, we're not adding, subtracting, just bring it down. Multiply. 3 times 2 is positive 6. Add down. 0 times 2 is 0. Plug that into the next slide. And add down. 0 times 2 is still 0. Add down. Negative 5 times 2 is negative 10. Add down. Again, once I've got that set, look at whatever degree you started with, and we start 1 lower than that. And yes, even with the zeros, just keep going. 3, 2, 1. There's my constant term because I ran out of exponents. 0. And this is my remainder, but there's nothing there. Which for my case is a good thing because now it means that x minus 2 is a factor of this. And if we were doing the other thing, I still could go to my calculator and look for a 0. I could try to factor this to find another 0. Like I said, right now, I just want you focusing on, hey, if I do synthetic division on this, do I get a remainder of 0, meaning it's a factor? If that's yes, that's true, and we'll deal with more of the factoring as we move on in the week. So, your job, play with some of the rest of these. Reinforce the lesson, okay? And we'll be seeing some more of this, along with a little bit of analyzing some graphs starting tomorrow. So get on that. Get on quiz stuff from before to get you ready for that. And we'll check you on later.